Today, we are presenting our project real-time UPI transaction fraud detection using hybrid AI. UPI processes over 10 billion transactions in a month, but its instant nature makes fraud instant and irreversible. As you all know, in credit card, there will be two-step verification where the money reaches to the other bank account after the settlement. So, if there is any fraud detected within 24 hours, it can still be avoided. But in UPI, it's irreversible. Once you send the money, it directly goes to the other person's bank account. Coming on to the problem and the social impact. Fraudsters today use sophisticated method, fake payment screenshots, refund scams, impersonation of customer support, QR code tampering, and coordinated mul account networks. Victims are often first-time digital payment users, rural populations, senior citizens, and small shopkeepers. The social impact of solving this is massive. We protect vulnerable users, strengthen digital trust, and reduce national financial losses. Coming on to our solution name is Fraud Site Pro. It's an AI-powered UPI transaction risk intelligence system where we use three-layer AI backend. The first one is a rule engine. It detects obvious behavioral anomalies such as new device, unusual hours, and transaction burst. Like consider if the person is usually sending like around around a day transaction would be around 1K, but suddenly it increases or multiplies by 15 times or 20 times. That's a very unusual behavior that takes place. Here we generate the transaction data. As we all know, we don't get transactions data from the bank or any sensitive sources. So we are generating it using the Python automation where we are getting the transaction ID, the timestamp of which he is sending, the sender ID, receiver ID, the amount, and this scores are the ones which our three layers of models are going to calculate. And going on to the next layer of our model, which uses a deeper machine learning model, which is isolation forest. It's an unsupervised anomaly model. We are using an unsupervised model because the fraudsters never use the same patterns. If they're using the same patterns, we could have used the label data sets and supervised machine learning model. So we need to use an unsupervised model where it detects deviations and includes unseen fraud patterns. Like even we know that the fraudsters are quite smart than compared to others. And going on to the third layer, graph intelligence, it identifies coming on to the next one, that is the graph intelligence. It identifies the mul networks and fraud rings by analyzing the connections between the between the two accounts, that is the receiver account and the sender account. You can see many mul networks are there. Like here, the red color network, the red node. You can see that it is receiving like the amount from many different users. It's receiving suddenly the spike in the increase of the money from many different nodes to see one single node. The traffic increasing over the one single node. It shows something fishy, and we report it as a fraud. And our ML engine uses isolation forest because fraud data is sparse and constantly changing. The model learns from clean simulated transaction and detects anomalies using transaction amount patterns, time of data cyclic encoding, velocity features, device changes, and sender receiver behavior and graph central features. Here even you can see that we even take the receiver's location, and the intervention, like when we temporarily block them, we even mention the reasons also. Like you can see a person has got high value transfer, so has been blocked over here. And the another one, and even in the unusual hours, like suddenly during the night time, we know that most of the scam process goes on. And even the suspicious device, like the mobile registration process has been logged in a different IP address for mobile number, and the transaction has been taken place in the other different phone. That also it gets detected. And even the location, geolocation irregularities. Like 5 minutes ago, they would have did the transaction in Chennai, but after 10 minutes, they would do in the next transaction would be in Bangalore. That's quite impossible, right? So even that is going to be predicted in our model, and it is going to be declared as a fraud, or it is going to be flagged. And coming on to the conclusion, why our solution stands out. What makes our solution unique is that it combines behavioral rules and supervised machine learning to find the hidden patterns, and graph theory, which is very important to find out the mul network bank accounts, and explainability and interventions. Most fraud systems rely only on the rules or only on ML. Ours unify three intelligent layers for a bank-grade fraud detection engine.